We want to verify that this series, so the sum from n equals 0 to infinity, 3 to the n plus 7 over 3 to the n plus 3 diverges. Okay. Now notice that I have 3 to the n and 3 to the n plus 3 in the denominator. So in the long run, we know that this is not going to go to 0. So we're going to use the nth term test. So we're going to take the limit as n approaches infinity. And here we're going to multiply top and bottom by 3 to the negative n power. So here's why I'm doing that. Basically, that's the same thing as dividing everything by 3 to the n. Because 3 to the n is the highest term here. You know, technically 3 to the n plus 3, but you know, you can think of 3 to the n plus 3 as 3 to the n times 3 cubed. Okay. So I'm just going to keep it simple. Let's just multiply everything by 3 to the negative n. Now we want to distribute the 3 to the negative n to both 3 to the n and 7. And then here in the denominator, they have the same base, so you're just going to add the exponents. Okay. Now, with 3 to the negative n, it's going to look something like this. And at 0, it's going to be 3. Sorry, at 0, it's going to be 1. So as n approaches positive infinity, this thing should go to 0. Okay, so you basically have 1 over 3 cubed, which is 27. That's your limit, which does not equal 0. Thus, by the nth term test, this diverges. Now let's look at another example. We want to see whether this converges or diverges. We have the sum from n equals 1 to infinity, negative 1 to the n plus 1, all over the square root of n plus 1. So this is an alternating series. I know that because of the negative 1 to the n plus first power. So here we have to look at all the conditions of the alternating series. So you want our sequence a sub n, which in this case is 1 over the square root of n plus 1. And the plus 1 is outside of the square root. We want this to be positive. We want a sub n to be decreasing, and we want it to go to 0. So is 1 over square root of n plus 1 positive? The answer is yes. Is it decreasing? Yeah, this is decreasing because the square root of n in general is an increasing function. So if I add 1 to it, looks like that. It's still increasing. So in other words, this whole denominator is increasing, which makes the whole fraction getting smaller, decreasing. Okay, so that's good. Does this go to 0? Well, yeah, as n approaches infinity, the denominator is going to infinity. So the top is going from negative 1 to 1, alternating, and that's obviously going to 0. So all three conditions are met, therefore this converges by the alternating series test.